Alright, my dear children of class 12 science, let's continue with solving the numerical problem, MCQ numerical problem. Now we will solve only two numerical problem from this chapter, that is alternating current. Now in the last YouTube video, we had solved up to question number 12. Now let me go to next question, question number 13. Now this question says that a 2 microfarad mu m, this is microfarad children, so 2 microfarad capacitor, 100 ohm resistor and 8H inductor, means 8 Henry inductor, is connected in series with an AC source. Now the connection has been given out here. This is LCR circuit. What circuit? LCR circuit. Okay. So all three components are connected in series with an AC source of almost 220 volt. Then after question says that the peak value of EMF or the voltage of the source is 200 volt. So peak value is how much? 200 volt. Now with reference to this question, so we need to solve the different part of the question. And the first part of the question says that find the frequency of the AC source for which the current drawn in the circuit is maximum. And the option is 39.8 Hertz, option B is 45 Hertz, option C is 25.6 Hertz, and last option D is 20.8 Hertz. Okay. Now in order to solve this question, okay, first part of the question, we do the calculation. Now in the first part of this question, we need to calculate the frequency of AC source, that means F. But in the question what is given? Capacitance is given 2 into 10 minus 6 farad. See, I have written already direct in what farad, because it is mentioned 2 microfarad, but microfarad can be converted into farad, that is how much? 2 into 10 minus 6 farad. Your resistor of resistance is how much? 100 ohm. Your inductor of inductance is 8 Henry. And the peak value of voltage is also given, that is 200 volt. But children, in this question, the voltage that is given by the AC source is 220 volt, and this source voltage is basically RMS voltage. What voltage? RMS voltage. Now, in the first part of the question, what we need to calculate? The frequency of the AC source when the current is maximum. And children, you know that for maximum current in what circuit? LCR circuit. We are dealing with LCR circuit. The frequency of AC source is also called resonant frequency. What frequency? Resonant frequency. And the formula is F0 equals to 1 by 2 pi square root of LC. So what is the formula of resonant frequency? That we are supposed to calculate for maximum current in LCR circuit, that is 1 by 2 pi square root of LC. So we can substitute the value 1 by 2 pi square root of L means 8 Henry into capacitance is 2 into minus 6. Okay, now we can simplify this further. Okay, when you simplify this, now 8 to the 16 inside the square root, but 16 square root is 4, so I have taken out from the square root. So 1 by 2 pi is already there, square root of 16 is 4. Now square root of 10 to minus 6 is 10 minus 3. Now this 10 to minus 3, if I take in the numerator, is 10 to the power 3, but 10 to the power 3 means then 1000. Okay, divided by, now 2 4s are 8, and 8 into 3 pi value is 3.14, which means 1000 by 25.12. So this 2 multiplication means 25.12. Now if you divide 1000 by 25.12, okay, you get the frequency 39.8 Hertz. So you can check with the help of calculator. Our frequency of the AC source, which is also called resonant frequency, is 39.8 Hertz. So children, under this question number 1, the correct option, as you can see, is option A, 39.8 Hertz. This is the correct option for frequency of AC source. Now in the next part of the question, we need to calculate the inductive and capacitive reactance of the circuit. Inductive and capacitive reactance. Now the circuit which we are dealing when the current is maximum is actually a LCR circuit at resonance. And you know, at electrical resonance for LCR circuit, inductive reactance and capacitive reactance are equal, and that value we need to calculate. Now, as you know, the formula of inductive reactance is XL equals to omega L. So omega means actually 2 pi F. Children, omega means 2 pi F, and this is L. So let's substitute the value. 2 pi means 3.14, F means 39.8 that we calculated, into L means 8. So if we do multiply all this quantity you get approximately 1999.5 something like that, but we can round up this value to what whole number, that is 2000 what ohm. So this is XL, so approximate value is 2000 ohm, which is a what inductive reactance. But what is capacitive reactance? 2000 ohm only. And you know why capacitive reactance is also same as inductive reactance? Because XL equals to XC, because we are dealing this question under the electrical resonance condition, because for maximum current in LCR circuit, XL equals to XC. So the correct option is, you can see the option is what? Option number B. Yes, 2000 ohm. So second part question option is correct, option number B. Then the next question is number 3, the total impedance of the circuit. Now in electrical resonance circuit of LCR circuit, the impedance is minimum and that is equals to resistance. That means this total impedance of the circuit is equals to resistance. And you know what is the resistance of the circuit? That is 100 ohm. So if resistance is 100 ohm, the impedance also equals to resistance, that is also equals to 100 ohm. So children, the correct option of total impedance of the circuit is first, that is 100 ohm. Okay, now we have to calculate the last part of this question. The question says that the peak value of current in the circuit. The peak value of current can be calculated by the formula, and the formula is I naught peak value of current equals to peak value of voltage by impedance. This is actually the formula, but impedance equals to R. Impedance equals to R, that we have already calculated, but this is true when the LCR circuit is under what electrical resonance condition, means Z is minimum, that is equals to R. So your peak value of voltage is 200, sorry, the resistance is 100, so if you divide, it is 2 ampere. So what is the peak value of the current? 2 ampere, and the correct option you can see number 4 is option C, 2 ampere. So peak value of current in the circuit is 2 ampere. So this is the explanation of question number what? 13. Now we discuss the last question, that is number 14. This is also important question. And question number 14 says that a resistance R equals to 30 ohm and a reactance XL is 40 ohm are connected in series across an AC source of peak EMF, that is E naught, that is also called voltage, 220 volt. Now this question also has 3 different parts. In the first part of the question say that what is the impedance of the circuit? Means we are connecting 2 different components. One is resistance, another is impedance. Means the circuit is LR circuit. What circuit? LR circuit. In LR circuit, we need to calculate the first part, that is impedance of the circuit. Then after, the peak value of current in the circuit. And lastly, the phase relation between voltage across inductor and resistor in the circuit. So in order to solve this 3 different part of this question, let's start with the first part of the question. And children, in the question, what is given? The resistance is given. For this question of 14, resistance is given 30 ohm. Your inductive reactance is given how much? 40 ohm. Okay. Now the peak value of the EMF, that is E naught, okay, mentioned is given 220 volt. So what we need to calculate for the first part? The impedance of the circuit. Now for LR series circuit, the impedance is given by the formula. Impedance Z equals to square root of what? R square plus XL square. So children, look at the formula. Z equals to square root of R square plus XL square. Okay. So R, resistance is 30 ohm with whole square. XL is 40 with whole square. Square root of 30 square means 900. 40 square means 1600. So 900 and 1600, if you add, that is 2500. And the square root of 2500 means how much? 50. And unit is ohm. So what is the impedance of this circuit? 50 ohm. So children, question number 14, first part, correct option is 50 ohm. So this is 50 ohm. This is 5 ohm. This is 50 ohm. And that is option number B, 50 ohm. Now the next part of this question, where we need to calculate the peak value of the current in the circuit. Now in LR circuit, the peak value of current means peak value of voltage by impedance. So children, the second part of the question where we need to calculate peak value of current I naught equals to peak value of EMF means E naught by impedance. So E naught is how much? 220. That is already given in the question. Okay. Now impedance is given how much? 50. So 0, 0 cancel out. Now 22 by 5, if we divide, it will be 4.4. And the unit is ampere. So 22 by 5, if we divide, is 4.4 ampere. So what is the peak value of the current? 4.4 ampere. Therefore, the correct option of question number 14, second part is 4.4 ampere. Option number C, 4.4 ampere. Okay. Now we do the last part of the question where we need to find the phase relation between voltages across, voltages, not only voltage and current, voltages across inductor and resistor. Means we have 4 options. One is 0 degree, option B is 45 degree, option C is 90 degree, and option D is 180 degree. So we need to calculate the phase differences between voltages across inductor and resistor in LR circuit. And children, in order to solve question number 4th part, so this can be done with the help of Phasor diagram. So there is a Phasor diagram between voltages and current. So if you look at this Phasor diagram, this is for LR circuit. Now current is always taken as x-axis. Now you know, in case of LR circuit, voltage across resistance and current are in the same phase. In which direction the current is directed? X-axis. BR is also directed along x-axis. Now in case of LR circuit, voltage across inductance always lead the current by 90 degree. How much degree? 90 degree. So BL leads the current by 90 degree. So if BL leads the current by 90 degree means BL also leads the voltage by 90 degree. So this 90 degree now is the phase angle between voltages between inductor and resistance circuit. So that means what is the phase difference between the voltage and resistance across inductor and resistance circuit? So we can see the difference is how much degree? 90 degree. So the correct option is option number C. So question number 14, third part, correct option is 90 degree. Okay. So children, I have explained almost all important numerical questions from alternating current. Okay. MCQ question for semester 1 examination, and this question will definitely help you a lot to solve other problems also. Okay, for your semester 1 examination. Okay. So in case in any of the question, if you have any doubt, so you can always ask to clear your doubts. Okay. Thank you so much.